Good afternoon everyone, and welcome to the first part of a 3-part worked exam answer little mini series. And the only reason why I'm choosing to do this way is I've picked an amount of substance question that has 3 calculation parts and then a structure and bonding part at the end. And rather than try and tackle this all in one video, I'm trying to break it down into shorter, more digestible pieces. So in this video we'll do part A, in the next video we'll do part B, and then we'll do part C and D in the final video, and these will be posted tomorrow and Saturday. So I've chosen an amount of substance question because these tend to be questions that students in year 12 find tricky. They're questions that still come up in year 13 papers, and it's just good to consolidate something that is going to be examined at the end of the year, sort of frequently as we go along. So I chose this question because it had 3 different types of calculation built into one question. So they're all based around zinc. And in this first question, we're told that people who have a zinc deficiency can take hydrated zinc sulfate, which means that the zinc sulfate has these waters of crystallization present in the formula, and that makes it hydrated. When we heat the hydrated zinc sulfate, what we're going to do is we're going to drive off those waters of crystallization. So the anhydrous zinc sulfate that is made will be ZnSO4 without these waters of crystallization. And we're told how much of the hydrated zinc sulfate we're heating, and we're told the mass of the anhydrous zinc sulfate formed, and we have to use these data to calculate a value of the integer x in the hydrated compound. So x has been used to represent any number, and it's our job to work out what that number should be. And different anhydrous compounds will have different numbers of waters of crystallization, or they will exist in different ratios between the anhydrous solid and the water. So for example, copper sulfate, X would be 5. There are other salts that are 2, I think. Magnesium sulfate I think might be 7. So they're all a little bit different. So the only way we can figure this out is to work it out via a calculation. So the first thing that I'm going to do is write a chemical equation to show the heating of the hydrated zinc sulfate, where that will become the anhydrous zinc sulfate, and however many waters we've got, that number of moles of water will be driven off when we heat the hydrated zinc sulfate. We know that the mass of the hydrated zinc sulfate is 4.38 grams, and we know that the anhydrous solid left at the end is 2.46 grams. From there we can work out how much water was driven off based on conservation of mass. We cannot lose any of this 4.38 grams. All of it has to be within the products somehow. So the remaining mass will be the mass of water. So 4.38 take away 2.46 gives me 1.92 grams. And I'll just write there how I got that. And what we're going to do now is an empirical formula calculation, but we're not doing an empirical formula calculation to find the ratio of atoms in a compound. We're doing an empirical formula calculation between the anhydrous zinc sulfate and the water. So we've got the masses. The next row that we would need is the MR. So 2 for the 2 hydrogens plus 16 for the oxygen. MR of water is 18. And then zinc is 65.4, sulfur's 32.1, and then we've got 4 lots of 16 for oxygen, and that comes to 161.5. And then, as with all things in amount of substance, we want to be thinking of comparing in terms of moles. So next step would be to work out the number of moles of both the water and the anhydrous zinc sulfate by doing mass divided by MR. So 1.92 divided by 18 gives me moles of 0.10, and then it's 6666667, so I'll write it as 0.107, and then 2.46 grams divided by 161.5 gives me moles of 0.0152. And what we should always find at this point is that the smallest number of moles is for the anhydrous compound, because then when we're working out the simplest mole ratio, we will be dividing both of these mole values by this smallest number. And that's what we do in any empirical formula calculation at this point. We divide through by the smallest moles. If the smallest moles was water, that would give X to be 1, which it might be, but that also then means that the amount of this wouldn't be 1, and then our balanced chemical equation wouldn't work. So you should always have a smaller number of moles here, and then I'm going to divide, like I say, through by the smallest moles, which for the anhydrous zinc sulfate gives 1, and then whatever value we get here, this is going to be the value of X. So if I do 0.107 divided by 0.0152, I get an answer of 7.00. Now it says calculate the value of the integer. It is 7.00271, but the integer will therefore be 7. And as with other empirical formula calculations, we can't be wildly rounding numbers up to the nearest integer. So had I got 6.5, I wouldn't be rounding that to 7. Had I got 6.995, yes, I could have rounded that to 7, just like I have slightly rounded down from the full answer here. That tells me, as I said, that X equals 7. So the formula of the hydrated zinc sulfate would be ZnSO4.7H2O. Job done. That's where I'm going to hold it for today's video. If there's any questions on this particular empirical formula calculation or any other empirical formula calculations linking to waters of crystallization or any other empirical formula calculations, as always, please do let me know. If anything in this video is unclear, again, please let me know. Thanks so much for watching, guys, and I hope that you found that useful.